Hello everyone, welcome to my YouTube channel. Today we are going to talk about system design, not from a tool perspective, but from a thinking perspective. System design sounds scary, right? Microservices, Kafka, load balancer, distributed systems, and what all. Sometimes interviewer expect you to design Netflix in 45 minutes. So, I used to think system design was about memorizing tools, but after a few interviews, a good interviews, I realized something important. System design is not just about tools, it's about thinking clearly under pressure. And I'll be honest with you, I missed some really good opportunities because of system design interviews. I was able to crack DSA, but when it comes to the system design rounds, I wasn't able to get shortlist even. But when the conversation shifted from code to architecture, the confidence dropped in, not because I didn't know things, but because I didn't have a structured way to think. I had ideas but no framework. And in system design interviews, unstructured thinking becomes very visible. That's when I understood this round is not testing how much you know, it's testing how you approach problems that don't have one correct answer, how you ask question, how you handle situations. So this video is not a tutorial. I'm not going to design Instagram or WhatsApp today. Instead, I want to share the mindset I wish I had earlier. Because once you start thinking structured way, the design becomes easy. Let's start with something fundamental. Today, scaling thoughts, not the system. One mistake I made early was assuming that scaling is mostly about traffic. But real systems rarely fail first because of traffic. They fail because of decisions. Decisions made too early, assumptions that turned out wrong, ownership that was never clearly defined. Good architecture is not just about building for scale, it's about knowing when to make decisions. Some decisions are cheap to reverse, others are extremely expensive. For example, changing a database later is painful, changing an API contract is painful, but changing an internal logic is usually manageable. Strong engineers understand this difference. They delay irreversible decisions until they have enough clarity. And in interviews, saying we can start simple, evolve this later does not make you look weak. It makes you look mature. Because good architecture is not rigid, it adapts. If we go to the next slide, why system design feels hard? System design feels difficult because it removes certainty. In coding interviews, you know when you are right. Your code compiles, test passes, there's closure, right? But system design has none of that. You are making educated guesses and explaining those guesses out loud. At the same time, your brain is juggling multiple dimensions: users, traffic, data, and what all, including failure scenarios as well, which depends on latency, cost, future growth, a lot of things to be precise. The consecutivity load is real. This is way structured thinking matters so much because structure reduces mental chaos. Also, interviewers intentionally change constraints during the decisions. They might suddenly say, what if traffic grows 10x? What if the service goes down? What if data consistency is critical? They are not trying to trap you. Trust me, they are testing your capability and your adaptability. Real systems changes. Good engineers adjust without panic. Once I understood that the interviews is simulating the real world uncertainty, I stopped chasing the perfect answer. I focused on being reasonable and clear. And that make a huge difference for me. And one of the most powerful things that helped me was having a default mental starting point. Because the worst moment in a system design interview is when your mind goes blank. Instead of trying off sound smart, I learned to follow the journey of data. Where does the request enter? Where is it validated? Who takes responsibility for it? Where does it get stored? What happens afterwards? This simple progression converts chaos into steps. Interviewers don't expect magic, they expect structured movement. And something interesting happens when you show structure. Interviewers begins to trust your thinking. When there is no structure, they stay in fundamental questions. But when you follow clear structure, they go deeper. Now the conversation becomes collaborative instead of integrative. Also, different systems stress different parts of this flow. In payment systems, validation and redundancy dominates. In messaging system, asynchronous behavior dominates. In file uploads, storage strategy dominates. How you're storing your files in S3 or all kind of things. Recognition that is strong signal of architectural awareness. With that, if we go to the next slide, that architecture is not just about diagram. Early on, I believed architecture meant driving clean resources, drawing clean diagrams with the perfect boxes. But diagrams don't make decisions, people do. Architecture is really about trade offs, trade offs which you need to take on. What are we optimizing today? What pain we are willing to expect tomorrow? Every system has weakness. Strong architectures know where their system is weak. Weak system fails because nobody acknowledges those weaknesses. Another overlooked aspect of this architecture ownership is when something fails in production, who owns the fix? Who owns the retries? Who owns the consistency? Who owns the data correction part? If responsibilities are unclear, system becomes unpredictable, and unpredictable systems are hard to operate. So, good architecture assigns responsibility intentionally. Diagrams are just a way to communicate those decisions. They are not decisions themselves. Before jumping into solutions, great engineers always think about questions, do's and don'ts basically about it. Not to delay but to prioritize. Here's the truth, you cannot optimize everything. Trying to optimize everything usually leads to over engineering, which most of the people do. If traffic is uncertain, don't overscale the infra. If correctness is critical, accept slower operations. If business logic changes frequently, design for flexibility. System design is largely the art of choosing when you are allowed to be weak, and strong candidates are comfortable admitting trade offs. They say things like, this improves latency but increases complexity. This simplifies operations but costs more. That honesty builds credibility as well. Pretending your design has no downside does the opposite. Also remember, most systems don't fail during launch, they fail during change. When usage pattern shifts, when data evolves, when new features stretch old assumptions, designing for change is often more important than designing for day one. So, what really matters in system design? It's the behavior over the time which matters a lot in system design. Creating a system is easy. Handling failure is where the engineering begins. Retries introduce subtle dangers, duplicates, race conditions, hidden load. Recovery demands the observability. Deletion demands discipline because nobody plans cleanup early. In fact, the maturity of system often shows in how well it handles the data lifecycle. Another lesson many engineers learn late, if debugging takes days, the issue is rarely intelligence, it's visibility. Good systems answer questions quickly. What failed, where, why, what is the impact, and if your system cannot tell this story, it will drain your team. And systems that don't scale humans eventually collapse. So when designing system, don't just ask, will this scale technically? Ask, will this remain understandable 6 months from now? Because clarity is what keeps the system alive. My final thought would be architecture is thinking under constraints, not perfect thinking. not fancy thinking even. Clear thinking is the one which is important. So don't just scale systems, scale your thinking. With that, if this helped you see system design differently, consider subscribing. Let's build better systems and, more importantly, better thinking. I'll see you in the next one. Thank you so much for watching this.